Snitch on my Welch's sparkling grape juice bottle.
Well, that's good.
I know that you were kicked out of your room.
What's? Oh yeah, we did.
Yeah, it was exciting.
Mm-hmm. Good times.
You should have been like, SWAT is here to catch me.
Mr. Hathaway, where will I be in 10 years?
Oh, no.
What should I say? Something interesting. What should I say? But
Does.
preferably not.
No, he joked that you should run to the door.
Oh yeah, yeah. When we were outside in the hallway when the dogs were in the room, I said I should just book it like outside or something. That'd be fun. I don't know. Where do we think Jaden's going to be in 10 years?
I'm sure if they saw you running, they would.
I would have looked up an exit.
And, like, so drug dogs are just failed fighting dogs because they couldn't fight hard enough. So they can still fight you. It's not as hard as the
Interesting.
fighting dogs.
Digging up dirt on police dogs there.
My dad is the canine sergeant.
Okay. That's awesome.
That was a great job.
Were you in the SAT room?
No, I took it last year, so.
Can I rant for a minute? Okay, so everybody was freezing.
The windows.
So, Mr. Langenkamp was like, if at any point you're cold, feel free to go close a window. And then during the test, people started getting up to close the windows because everyone was freezing. And then the other lady kept coming in and opening them back up right away.
Yeah, this is game
And then-
opening.
She was playing games.
Oh,
Yes,
virus
yes.
stuff.
And then everyone just kept closing the windows, and she just kept opening them right back up. And then people asked her to close them, and she was like, "No, we need air circulating." And everyone's like, "No, everybody's freezing." And she's like, "No, we want air." And everyone was like, "We don't."
Oh my
Everyone was
goodness.
just freezing. She kept closing her.
I think Mr. Nessie closed them.
Yes, and then she got switched off from Mr. Netsky, and Mr. Netsky would just close them all for us, and everyone was just finally not freezing.
Oh man.
Did they all cheer? Did they all cheer?
No, but we were all silently thinking. We weren't allowed to talk.
That's why everybody in my, I think it was 5th hour, walked in and they said they were freezing. I turned the temperature up because it sounded like you guys had a pretty rough time down there.
He's like, feel free to close the windows. And then when we did close, they got opened up right away.
These first 2 minutes of the people watching in 10 years are going to be like, why did I waste 2 minutes on this?
No, they're probably intrigued. I bet you they'd be cold too.
with you to make the title what time you actually
Right.
Yeah.
Fast forward to 7
Yeah,
2
minutes.
minutes and
in
3
10
seconds.
years?
Jaden complaining about windows. 5 minutes and 3 seconds. The actual
Oh, you
start.
can put titles on your video now.
No,
It's
and like honestly,
no
they're thinking
chapters.
about getting rid of the ACT and SAT. So in 10 years, when people watch this, there could be no ACT or SAT. They could be like questioning why I'm speaking right now.
Yeah,
Probably.
that makes sense. No,
I mean, I'm
Or
sure
maybe
they'll
they'll
always-
question why anyway.
Yeah, I'm like, people always question why this voice speaks, but even more so now.
As a parting comment before we jump into physics, I think it's funny that you have dirt on the canine dogs, so that when they come in you can be like, oh, you didn't have a hard enough bite to be a real police dog.
Unless they're
You
both.
found drugs in Placido's car.
They could be both.
Well,
There are dogs that train on both.
They won't be in his car, they'll be on his person.
At least Placido bites hard.
They could be both. It depends on what department they come from.
What if I have
And how
epinephrine?
many dogs they have.
That's set off to no.
You'll have to find out.
Wait, what should I ask my dad?
Wasn't that for,
Epinephrine.
you gotta like take an injection for that if you're susceptible to something?
Yeah, it's EpiPen.
Oh, that's what that is, yeah, yeah.
I don't think. I think it's probably airports.
for being
They might hit on it depending on the dog. I'm sure at the airports they hit on it just because the needle also. But
And we're right at 4 minutes. This is where the physics starts. 4-minute physics. So the question is, turns on high-speed roadways tend to be banked. What do you suppose that is?
to increase friction.
Increased friction, because if you have those roadways being banked, then you will have an increased normal force because you'll be going into the road instead of sliding off of it. So that increased normal force will provide an increased force of friction. Now, I just wanted to make sure that we were okay with everything we did yesterday before I jump into what we'll be doing today. So, that's what this is going to be for. Yesterday, you don't have to draw or pay attention if you're cool with what happened yesterday. I just want to make sure that we're all on the same boat here. We got this object and it's being slung around in a circle like this. And what we were trying to do is figure out a general way to represent its tension force and its acceleration. Because as it goes around in a big circle, both of those things are changing. So this is our object at some random point, and we've got gravity acting down, tangentially, we will have a portion of that gravity acting. So this is tangential to the direction that this object is moving at that point in time. So that force is going to be associated with gravity in this direction. Now, in addition to that, you'll have part of this gravity acting in this direction, in the same plane as the tension force. Those two forces need to be defined in that way because those are the two directions that we are concerned with. The tangential direction and the centripetal force direction right here. So that's where those two things come from. We know this is Fg cosine theta because this is the angle and this is the adjacent side. And this would be Fg sine theta. That's where this comes from over here. Instead of using Fg cosine whatever angle this is, I just used Fg sine theta because that's the same as this side of that triangle over there. So that's what all those letters mean. And just kind of backing out,
Or technically, maybe just do FG cosine of whatever minus 90.
yep, you could, but we want to try and figure out what the relationship is particular to this angle. So that's why I left it in. So tangentially, we can solve for acceleration because, you know, this is the force that's acting tangentially. We set that equal to ma, and this t stands for tangential acceleration. This is the acceleration that's occurring in the direction the object is actually moving. So, when we solve for acceleration, the m's go away, we're left with g sine theta. And that's what the acceleration is when you're looking tangentially. In terms of the centripetal motion, in terms of the forces acting, keeping it moving in a circle, we've got tension minus Fg cosine theta, and that's what the equation was over there, and that's equal to mac. So this is your centripetal acceleration, because it's the acceleration that's acting to keep it moving in a circle. And when we went through that, we wanted to solve for the tension force. When we do so, we end up with this expression, and that's where that comes from. It's just a matter of doing this same idea, adding up all the forces in the opposing directions, but you're just doing it with respect to the circle or with respect to the tangent. That's just a little bit of a review there. And this is more complicated than the stuff you'll need to do on the homework, but it's the sort of thing that I want you to try and be comfortable with. Okay, on to today's lesson. Today we are going to talk about resistive forces.
I like the words we use in this class.
Yeah.
Resistive.
And
Makes me think of phrases.
I was going to say, it's really quiet.
That's not
You're
getting
the
positive.
fan.
I'm not,
You can.
I'm not complaining.
Did it actually break, or did you just?
I'm pretty sure that the problem is the fan on the inside, so I just took a desk fan and I duct taped it up there.
Wow.
It's worked so
That's
far.
like doing it for that last year or earlier this
Yeah.
year. Design calculator.
There's a lot of circular motion going on in that fan.
Let's calculate. Wow.
If Jaden punches it at this degree, which direction will it come?
Now, there's two ways that we can define how to deal with these resistive forces. We can define the object that's moving in the air as a particle, something with a minimal amount of surface area. And if we do that, we're defining it as like a little tiny particle. That's a pretty rare thing that we can do, but it's good to be aware of it. And if we define our resistive force in terms of a tiny, tiny particle, that resistive force is going to be equal to BV. And this is going to be a negative number, but I'm not going to put a negative in here because when we do the force diagram, that minus sign takes the negative into account. The B in this equation is just a constant, and it's dependent mostly on the air density. So when we're dealing with these resistive forces, you can think of it in terms of a force diagram. Of course, we've got gravity going down, we've got resistive force going up, and it's tempting to create a force equation out of this and saying resistive force minus gravity equals 0. What's wrong with that? Yes, because whether it's friction or whether it's air friction, that is always going to be the negative in your equation. So in this case, gravity is going to come first. Resistive force comes second. Of course, that'll be equal to MA. And this is where we take that negative into consideration, because resistive force is a negative number. So if you wanted to solve this for your acceleration, it's pretty straightforward. Force of gravity is mg. Resistive force is bv. And I would just isolate that acceleration. Sure can. So that would be how you would define your acceleration.
Why is it still M?
Because it's subtraction, you can just get rid of it.
Yep, because there's no m with the bv, so this is like saying mg over m minus bv over m. So that's where we land, and that's how you define your acceleration. One of the main things I want to do as we kind of go through this stuff is just continue to work on getting you comfortable with these letters when they're not in the presence of numbers. Because so often in this class, that's something that it's helpful to be comfortable with. Now let's say we wanted to solve for terminal velocity.
Okay, I always asked about this last year.
Yes, you did.
And air resistance.
Yep. So if we're solving for terminal velocity, what can we change about this equation? Someone will think of it. What was that, Sarah?
Do we isolate the V?
We'll definitely isolate the v. There's something else in this equation that we can do, though, to make it even easier to deal with. No. Differential equation.
Differential equation.
One of these letters will drop off the face of the earth. No. A, yes. Because when you've reached your terminal velocity, you're not picking up speed anymore. So your acceleration goes to 0. So for terminal velocity, 0 is equal to g minus bv over m. And then you can solve for the v.
So are we doing all our problems in terminal velocity? Or no?
It will be part of a lot of them, especially near the end of the chapter here. So solving for that velocity then, multiply both sides by m, divide both sides by v. I'll just put a little t next to the velocity so that we know it's terminal velocity. And that's what you get. Questions on this? We're going to take this one more step, because we can't always deal with these resistive forces as though they're the result of something that is of a negligible size. We have to take into account sometimes the surface area of these objects to be more specific, and that's where we're headed. We're going to finish with a lot of time to spare. That's good. I got some funny videos we can watch.
Right. miss those days. You always put up like a fail.
Oh, the fail army.
Yeah.
Now there's probably a whole new season that I haven't even seen.
Probably 2 of them.
Maybe.
So if we've got a larger body,
Oh, this is what I was asking about that you could see through the notes yesterday.
oh yeah, that's what you saw. So things get just a little bit more complicated. Instead of saying BV, resistive force is 1/2 d rho AV squared.
So in that question,
Yeah.
it's going to tell us if they're higher particle.
Yeah, they'll be specific. So in this equation,
This was in our book.
yeah.
Because it was a lot shorter sound, so I didn't.
D is your drag coefficient. Rho is your air density. A is your area that's perpendicular. Whoops. So as you're falling, whatever area is perpendicular to the direction, that's what that would be. And V, of course, is velocity. And we'll just do a quick problem with this, and then we'll be good. I have lots of time to watch some cool videos.
We're playing a house as a class.
There we go. I'd like to run the videos though. If you guys want to do that, feel free. I want to run the videos though to make sure that this works because it died on me twice today, and then I put the fan up, and so far it's good. I'm hoping it stays that way.
I thought you had that up there.
I had it up there last year, and then I figured out how to manually increase the speed of the fan on the inside of the projector, and now even though I do that, it's not working again. So
Because when I came in here last year, I remember you doing something with the thing.
I thought I remember the fan being up there. And
it was up there last year, and then I took it down when I didn't think I needed it anymore. It's always nice having a fan in the room. All right. So, what are we doing? Oh yeah, resistive forces. So, just like before, you're going to have, we'll use a freshman as an example.
Oh, yeah.
So, you can't,
So yes.
2 arms, 2 feet. And,
It's such a great
what do you think? Are they falling like face down or
Oh,
backwards?
definitely face down.
Face down, yeah. There we go.
that's fine.
So, they're falling.
Dumb enough to do that for fun.
It'll be fun on the way down.
As long as there's enough fat to
Not at the
catch
point of
them.
impact.
Right.
Mr. Hathaway, does he have a parachute as
Well, I don't see one.
I really appreciate how well I copied it down as well.
Good.
Sometimes you don't copy it.
No, sometimes you just have to appreciate it, and I appreciate that I can't draw it either. So I just gotta look at it and admire it, and then draw a little dot and know that that's what it is.
So, we've got our little friend here, and he'll be good to go for a while. And he's got gravity down, he's got resistive force up. So, what's the first thing in the force equation?
Gravity.
Minus resistive force equals ma. And so if we want to solve for acceleration, we do the exact same thing that we did before, except now it looks more complicated.
Look down for 2 seconds.
All right, so how's this going to be? It's going to be d rho AV squared over 2m?
Yep.
Okay. So I kind of skipped a math step in there. But you get the idea. It's the same work as before. You get there by the same mathematics. So, questions up to this point? So then if we want to solve for terminal velocity, imagine that. We do the same thing that we did to deal with it before. We take our acceleration and we set it equal to 0.
I keep forgetting that terminal velocity means what it means.
Yeah. This is going to take a little bit of math here. So then the 2m comes up.
Oh, shoot, now we have MG.
I remember when things were just
Back in the good days.
In the peace time.
Well, what value would you plug in that would be negative that would make the inside not negative so you could actually make that happen?
Yes.
I don't know.
Okay,
I'll get back to you on that.
because I'm like, the mass is a negative, gravity is a positive value at this point. Is drag negative or flow or phi or whatever?
D5.
No, I think those are all positive.
So, yeah, that does make sense. Well, you need the negative if you're subtracting,
Yeah.
so you forgot a negative on the board.
Did I?
Yeah, because when you
Zero.
oh wait.
Where'd it go?
You subtract the G over the, oh, never mind, the negative cancels out.
Okay.
He was going to make a mistake.
How dare you?
That's why you were like,
Give me her extra credit.
you were encouraging it. You were like, I'll get back to you. And I'm like,
Well, actually, to be honest, I didn't know what you were talking about when you said that. It's like, I don't want to look stupid on camera. I'll get back to you.
I respect
wow.
Anyway,
You know what?
AP Physics. So yeah, that about does it for resistive forces. Now, the thing that I do want to point out as we close this is when you're dealing with this, either on the worksheet or in the book, sometimes it's best, if you can, you don't necessarily need all three of these in order to solve a problem. You might be given a scenario where you can find the product of these three. And if you can do that, you're just as well off. So just kind of keep that in the back of your mind. The end.
Real quick, Mr.
But it's
Huff,
nice that they keep it
I wasn't
separate.
listening. What does DPA mean?
Debug.